Okay, well, welcome back, everyone. This is our first main session, Global Standards and Rigor in Quantitative Research. This session will focus on the quantitative method you will use in your educational research. I'm Unali, and let's start our deep dive. Here is the first part of our table of contents. We will cover 6 main sections. We will start with the basic approaches of quantitative research. Then we will learn about how to collect educational data properly. After that, we will look at statistical analysis methods and the important topics of measurement instrument like questionnaires. Finally, we will touch on ethics and publishing standards. The second half covers more detailed topics. We will examine experimental designs, including quasi-experimental method. We will review different statistical methods and popular statistical software options. Then we will learn crucial steps before analysis, known as pre-analysis procedures. A very important part is effect size and reporting. And finally, we will discuss research transparency to ensure our work is credible. By the end of this session, you should be able to do 5 things. 1. Understand the importance of quantitative research. 2. Develop or select reliable measurement instrument. 3. Learn ethical and practical data collection procedures. 4. Choose the correct statistical analysis method. And 5. Learn reporting method that make your work transparent and easy to reproduce. Before we start, let's do a quick icebreaker. I want to know a little about your experience. And so please think about these questions. Are you working on a research project now? And have you used a quantitative method before? What part of statistical analysis do you find most difficult? Please share briefly in the chat box. So, what exactly is quantitative research? It is a systematic way to collect numerical data and analyze it with statistics. The goal is to get generalizable results and objective evidence. The key characteristics are objective measurement using standard tools, structured data collection, statistical analysis to find patterns, hypothesis testing, and globalizability of findings. Why are quantitative methods important in education, especially in the Philippines? First, they provide evidence for educational policy decisions. For example, depth needs data to verify the effectiveness of the K-12 program. Second, these methods are crucial for evaluating educational programs. You can measure the effectiveness of a new teaching method or track changes in student achievement. Third, quantitative methods help with international comparison and benchmarking. Think of big international assessments like PISA or TIMSS. This allows to Philippines to identify strengths and weakness. Fourth, this approach is the best way to understand the large-scale phenomena, such as nationwide educational surveys, which involve studying a large number of students or teachers. Let's review variables. We have three main types. Independence variables are the variables that the researcher manipulates or changes, like different teaching methods or student hours. Dependent variables are the variables that are measured or observed, like academic achievement or student engagement. Other types are meditating, examples of how or why, and control variables, which we account for statistically. What are the current research trends? In Philippine education research, topics include the MTB, MLE implementation, and K-12 curriculum evaluation. Globally, trends include randomized controlled trials, RCTs, and meta-analysis. There is a strong movement toward evidence-based approaches, like replication studies and open science practices, such as pre-registration. You need to choose the right type of design. Experimental research is the strongest for finding causality, but it requires random assignment. Quasi-experimental research is very common in education because random assignment is often impossible. We use pre-resisting groups. Correlational research only examined relationships and cannot establish cause and effect. Survey research involves large sample size and is mainly descriptive. Standardization ensures academic credibility and research quality. It shows that your findings are based on systematic procedures. This is very important when findings influence policy decisions. Standardization also meets publication standards. High-quality journals like those in SSCI or Scopus require transparent reporting. Standardized procedures are also essential for meta-analysis. Measurement is the process of converting abstract concept into numbers. Variables can be measured using different scales. Nominal scales are just categories like gender. Original scales provide a ranking or order like grades. Interval scales have equal distance between points. And ratio scales have a true 0 point, like age or test scores. Now, let's discuss validity. Are you measuring what you intend to measure? Content validity means the instrument covers all aspects of the concept verified by experts. And criterion validity compares your measure with an existing standard. Construct validity ensures your instrument measures the theoretical concept actually. Validity is the foundation of quality measurement. The second key concept is reliability. This means the measurement is consistent. Internal constancy is checked with Chromba alpha, where 0.70 is acceptable. Test retest reliability checked if the results are stable over time. Inter-rater reliability checked for agreement between two or more people. Remember this core principle. You cannot have validity without reliability. Developing a new questionnaire following 3 steps. Step 1, literature review and concept definition. Clearly define your key concepts. Step 2, item generation and expert review. Write clear items, avoid double barrel questions, and get expert feedback for content validity. Step 3, pilot test and validation. Test your questionnaire with a small sample and conduct a vector analysis to finalize the instrument. A common format is the Likert scale. The 5-point scale is the most commonly used. And the 4-point scale eliminates the neutral option. When designing, ensure you use a consistent scale and consider including reverse coded items to check if participants are paying attention. Be aware of response bias patterns. Using an existing instrument saves time, but it requires translation and cultural adoption for the Philippine context. Developing a new instrument is perfectly tailored, but it requires extensive verification. My recommendation is open to modify existing instrument for your local context. If you adopt an instrument, follow the forward-backward translation process. Translators translate to the local language, and then another person translate it back to English. You compare the original with the back translation to ensure the meaning is the same. Always consider your target population's language proficiency and ensure cultural appropriateness. And you must have a clear data collection protocol. This is where ethics and permissions are key. Obtain ethics approval, secure DevEd permission, get principal's consent, parent consent, and student assent. You need to standardize procedures by using identical instructions. Always keep detailed field records and train your research team properly. Online surveys are great because they are fast, have automatic data entry, and are cost effective. But they require internet access. Paper-based surveys do not need the internet and often have a higher response rate, but they have time-consuming data entry. Choose the methods that the best suit your population. To increase your response rate, one, preparation. Secure principal support and explain the research importance. Two, timing. Avoid busy times like exam period. Three, survey design. Make the questionnaire concise and use simple language. Four, follow up. Send polite reminders. Five, incentives. Offer small tokens of applications or a certificate of participation. The population is the entire group you want to generalize to. The sample is the subset that participates. Proper sampling ensures your results actually and represent the population. You need to determine the right sample size using software like GPower to ensure sufficient statistical power. General rule, aim for 30 or more per group for comparisons. Probability sampling means every person has a known chance of being selected, which gives the best representative. Non-probability sampling is less systematic, like convenience sampling. In reality, in education research, true random sampling is often difficult because we use existing classes. If you must use non-probability sampling, we need to acknowledge the limitations. Educational data often has a hierarchical structure. Students are within classroom and classrooms are within schools. If you ignore this, you have an independence problem. Students in the same class are not independent, which can give biased results. The solution is multi-level modeling, MLM, which accounts for this hierarchy and provides more accurate estimates. Let's focus on quasi-experimental design. It uses existing interact classes. This design often uses a pre-post-test structure. You measure the dependent variable before the intervention and after the intervention. You can then analyze the data with ANCOVA to statistically control for any initial differences between the groups. This slide gives you an overview of the main statistical method. Descriptive statistics simply describe your data, mean, standard deviation, frequency. Group comparison method test differences. T-test for two groups, ANOVA for multiple groups. Relationships exploration method look at how variables are connected, correlation, and regression. For your thesis, you might use advanced analysis like SEM or HLM. You will need statistical software. The most popular commercial package is SPSS, which is user-friendly. R is free, but requires programming. Yeah, for beginners, I recommend Jamobi. It is free and very intuitive. For yeah, SPSS is good choice. To summarize, if you are a beginner, start with Jamobi, no coding needed. If you are an advanced user, R offers maximum flexibility and is the best for complex analysis. Before analysis, complete the pre-analysis checklist. Yeah, first, data cleaning, check, and the correct coding errors and impossible values. Second, missing data management. Calculate the percentage of missing data and decide how to handle it. Third, outlier detection. Use box plot and G-scores to identify outlier and then decide whether to keep or remove them. Continuing the checklist. Fourth, data screening. Check for normality, data distribution, and homogeneity of variation. Fifth, calculate your descriptive statistics, means, and standard deviations. Finally, assumption verification. You must verify these test-specific assumptions, such as independence of observations or homoscedasticity. Homoscedasticity. So the pronouns is difficult. Statistical significance is not the same as practical meaning. A p-value less than 0.05 only says a difference exists, not how important it is. Effect size are necessary because they help you determine if an educational invention is worth implementing. They provide the context for interpreting results. Here are the main effect size indicators. Cohen's d is for mean differences. 0.5 is medium. Eta squared is the proportion of variance explained. Correlation shows the relationship strength. 0.3 is medium. According to APA 7 standards, effect size reporting is mandatory. You must also report confidence intervals, CI. 95% CI provides a range of uh, plausible values for the true parameter. Modern statistical reporting requires a trio of information: p-value, effect size, and confidence intervals. This trio gives a complete picture. Why is transparency important? Because of the replication crisis. Reproducibility is the ability to other researchers to get similar research result using the same method and data. This crisis is caused by practice like p-packing, analyzing until finding significance, and selective reporting or only positive results. This undermines research credibility. To avoid this crisis, follow transparent research reporting standards. You need to report participant recruitment, sample characteristics, size, demographics, measurement instruments, full descriptions, validity, and data collection procedures, step-by-step protocols. Use official guidelines to help you. For experimental research, follows the consort guidelines. For observational research, follow the Stobbe guidelines. You can use it. Using this checklist ensures you do not miss any key information. The final step in transparency is sharing data and code. The benefits include increasing transparency and allowing peers to verify your findings. Data sharing follows FAIR principles, findable, accessible, etc. However, you must prioritize privacy considerations. Remove all uh, personally identifiable information. Anonymize participants' data thoroughly, and obtain proper consent. Where can you share your data? I recommend using data repositories. The Open Science Framework is a free platform for your work. PicShare offers free storage and tracks metrics. I think your university repository is also an excellent option for long-term preservation. Let's put everything into a research proposal framework. Your research question must be clear, specific, measurable, and testable. Define your variables clearly. Choose the right research design. Define your sample and report a power analysis. Finally, outline your analysis plan. Now, uh, this is a workshop activity. Uh, I think let's do a quick individual activity. Think about your research topic and write down these four things. One, a specific research question. Two, independent, dependent, and control variables. Three, the measurement method you will use. Four, your sample size and the statistical techniques you plan to use. I think you need more time to do this activity. So I recommend after my lecture, you need time to do this activity. If you want a feedback, you will make it and then give me two questions. I will give you feedback of your research plan. Here is an example. The question is, what is the effect collaborative learning on high school students' mathematics achievement? The IB is teaching method and DB is math achievement scores. We use a quasi-experimental design with 120 students. We will use a pretest and then ANCOVA for the analysis to control for baseline differences. We must avoid these common mistakes. Be careful of sample size issues. Don't use a sample that is too small and don't skip power analysis. Avoid measurement problems. Always ensure your instrument have verified reliability and validity. For statistical errors, check your assumptions carefully. And avoid reporting bias by not selectively reporting only positive results. This is your final quality checklist for a rigorous quantitative study. For research design, is the design appropriate? For sampling, is your sample size sufficient? For measurement, are the instrument validated and is reliability reported? For analysis, did you verify assumptions and did you include effect size and confidence intervals? Keep the journal requirement is in mind. They demand methodological rigor, appropriate design. They require transparency, detailed procedures, the very reproducibility, data sharing. They mandate ethical standards, IRB, ethical approval. And they usually require the APA 7 reporting standards. This slide shows you how to write a perfectly formatted statistical result using the APA 7 format. You must include four key elements: descriptive statistics, mean, standard deviations, the test statistics with good degrees of freedom, and exact p-value, and effect size, and confidence interval. To summarize, your statistical reporting must always include these four elements. 1. Descriptive statistics. Uh, Test statistics, t-score, F, or chi-square values. 3. Effect size. Cohen's D, R, shows practical significance. 4. Confidence intervals. When you read a research paper, use this framework for case study analysis. Check if the research question is clear. Check if the measurement uses validated instruments. And check the sample design. Was the size sufficient? And for statistical analysis, were assumption verified? And were effect size and CI reported? Finally, check if limitation and implications were clearly discussed. Let's quickly review the 5 key takeaways. 1. Systematic measurement. Define variables, use objective measures. 2. Reliability and validity. Instrument must be reliable and have multiple types of validity. 3. Appropriate design. Match the design to the question and control for variables. 4. Complete reporting. Always include the full statistical trio, descriptive states, test states, effect size, and confidence intervals. 5. Transparency. Document all procedures, share materials when ethical, and support reproducible research. We have an optional assignment to help reinforce your learning. You can choose one of these 3 tasks. 1. Draft a short 1 or 2 page research proposal using the framework we discussed. 2. Review one quantitative research paper and analyze its methodological strengths. 3. Find and evaluate a measurement instrument for reliability and validity. Completing this will greatly help your own thesis. I recommend you by yourself this optional assignment. Thank you all for your active participation in this session on quantitative research methodology.
Thank you so much, Professor Lee, for that valuable ideas. We're learning a lot from this exchange, Prof.